Welcome viewers to Usena Unique Agric Solutions. On our previous video, we looked at the benefits of vermiculture in general, but today we need to look at step-by-step benefits of vermiculture. So for today, we will be focusing on the science and practice behind each benefit. On today's episode, we will look on how vermiculture improves soil pH, CEC, and soil structure. So let's look on the soil pH first. What is soil pH? Soil pH is simply how the alkaline or acidic the soil is. It is measured usually from 0 to 14, where 0 is mostly the acidic and 14 is the alkaline soil. Most plants seems to do well in pH between 5.5 to 7. So what are we saying? The effects of high and low pH is that some nutrients will not be available to the plants. So for example, we have iron, zinc, copper, and manganese. They become solid when the pH is high. And also calcium and magnesium, when the pH is low, they become unavailable to the plant. It is also true that in high pH, calcium and manganese are very high, and this becomes toxic to the plant. And also on the other end, if the pH is too low, copper, zinc, boron, manganese, iron, they become too toxic to the plant. So this is where vermiculture comes into play. It gives the soil a natural buffer as it increases the pH in acidic soil. Also, since the worms, they survive well in pH ranges of 6.5 to 7.5. This means that they tend to work on the soil if you incorporate the vermiculture or the vermicompost in the soil. So by this, we know that the problem of soil pH, we have solved it. Our second issue is on cation exchanging capacity, which is also known as CEC. So before we explain on cation exchange capacity, please, if you have not yet subscribed to the channel, click the subscribe button and then the notification bell so that you won't miss tomorrow's episode. Okay, I will try to make it very simple and short so that you understand this easily. By definition, CEC or cation exchanging capacity is the measure of how many cations can be retained in the soil. In simple terms, it is the ability of soil to hold and store nutrients. To simplify this, nutrients exist in either positive charged or negative charged ions when dissolved. So the positive charged ions are called cations, while the negative charged ions, those are the ones that we call the anions. For example, of cations, we have calcium, magnesium, ammonium, potassium, hydrogen, sodium, aluminium, manganese, zinc, and copper. Also, on anions, these include chloride, nitrate, sulfate, phosphate, and molybdate. So when soil properties are negatively charged, they attract and hold cations. So which means we are saying when our soils, they have a negative charge, the cations, those ones with the positive charge, they attract to the soil as the rule of magnetism, so that the like poles they repel and the unlike poles they attract each other. So stopping them. So if now the cations hold to the soil, then this stops them from being leached away by water down the soil profile. Also, if the soil is positively charged, cations repel, like as I said before, like poles they repel each other, because now we have both positive charged. I think this is now makes sense why we say some soils do leach and then some soils they hold nutrients. Soils like sandy soils are positively charged, while clay and organic matter is negatively charged. So organic matter attracts and holds more cations, or those what we call positive nutrients. So soils with high CEC have ability to hold more cations which are positively charged, and also more soils with high CEC tend to hold more water. For example, these are clay soils and organic matter, while the low CECs is now hold less water. For example, we have sand. So in short, we are saying if we use vermiculture into our soils, we incorporate the ability of the soil to increase the exchanging capacity of these positive ions, which we call the cations. So it means if our nutrients are there in the soil where we have vermiculture within our soil, the soil has the ability to hold those nutrients and they will be not leached away with much water. So that is what we say about vermiculture advantages in terms of CEC. Last but not least, I'll look into soil structure. I'm not going to spend much of my time here because this is almost the simplest of all the things. Soil structure is generally the arrangement of soil particles and pore spaces located between them. It is determined by how soil granules bind together and aggregate, resulting in the arrangement of soil pores between them. There are 5 basic types of soil structure, which includes platy, prismatic, column, granular, and blocking. So by adding vermicompost or vermiculture, you will be adding or improving the soil structure. As you know, the soil structure, your particles or your water holding capacity would have been improved. I will not dwell much in these types of soil. Thank you guys for watching this video. Please don't forget to subscribe and press the notification button so that you won't miss any video on everything we are going to post. So stay tuned.